Welcome to our DIY on how to name and draw hydrocarbons. First, we're going to start by telling you what is UPAC. UPAC is the International Union of Pure and Applied Chemistry. This is an international scientific organization and it's non-governmental. It was created in 1919 with the purpose of standardization in chemistry, and it sets global standards for names, symbols, and units. The importance of UPAC rules is that we need a way to identify and classify hydrocarbons, and this way we avoid confusions naming them, and by this we are able to work and study them properly.
Hydrocarbons are organic compounds that consist of carbon and nitrogen atoms. These compounds can form chains and they can be classified depending on their bonds. There are two main groups of hydrocarbons, saturated and unsaturated. Saturated hydrocarbons are known as alkanes and they have only single bonds. Unsaturated hydrocarbons are known as alkenes and alkynes, and they have double and triple bonds, besides the aromatics. Aromatics are known as benzenes, and they look like rings. They have three pairs of double bonds, that's why they are unsaturated, and they usually release odor, that's why they have aroma in their name.
Okay, now we are going to talk about the alkanes. The alkanes are also known as saturated hydrocarbons. Hydrocarbons having no double or triple bond functional groups are classified as alkanes or cycloalkanes, depending on whether the carbon atoms of the molecule are arranged only in chains or also in rings. These are some examples of the alkanes. So there are some rules about UPEC for the alkane nomenclature. So the first one is to find and name the longest continuous carbon chain. The second one is to identify and name groups attached to this chain. Third one, number of the chain consecutively, starting at the end of and the nearest and substituent group. 4. Designate the location of each substituent group an appropriate number of a name. 5. And finally, assemble the name listing groups in alphabetical order using the full name. So we can identify the number of hydrogens that the alkenes have, and the equation that best describes this relationship is this one, where C and H are the atoms of carbon and hydrogen. And this is how some textbooks put the following the formula. The N it is we can substitute by the number of carbons that the molecule has. So let's talk about some example of alkenes. Sorry for this. So there are some these are some examples. Here we have the methane, that is the molecular formula, and the structural formula. We can name the alkenes depending on how many number of carbons they have. If they have in here we have two carbon atoms, we're going to have the prefix eth. So this is an eth, and as we are talking about alkenes, we have the suffix ane, and this is the ethane. Now let's the pentane. It has 5 carbon atoms, and so it is the prefix pent. here we see this. And as I already said, we're talking about alkenes, so it has the suffix alkane. So here it has. This is the molecular formulas, how they are represented, and this is the structural formula in a more graphical way. But what if these formulas are represented like a ring? So let's make a pentane. Let's suppose it's a painting. Sorry for that. So we have like 1, 2, 3, 4, and 5. These are the carbons. Here there's the hydrogen atoms. They should be like here. But if the formula is represented by a ring, we have to add the prefix cyclo. Pentane. If the structure is in a ring, it has to have the prefix cyclo. Thank you for watching.
Now we're going to move on with the alkenes. These are a different family of hydrocarbons with a specific characteristic that differentiates them. The alkenes have very similar characteristics to the other types of hydrocarbons. They just differ in a small amount of things. The first characteristic is that alkenes have double bonded carbon atoms. This means that instead of the alkanes having just one bond between the carbons, the alkenes have two. They also have a suffix which is "-ine" under hydrocarbons, which identifies them as alkene, and if you don't have the specific structure to identify if it's alkane, there's a formula to help you, which is CnH2n, which is going to identify if it's alkene or not. The steps for naming an alkene hydrocarbon. First, you obviously need to know if it's alkene, so the structure or the formula might help. The first step after knowing if it is alkene or not is to identify the longest carbon chain. This is made by seeing which is the longest carbon-hydrogen chains and counting them. Once you count them, you have to assign a prefix. By assigning a prefix, you have a name for the whole chain. Now you need to focus on the branches. The branches are those little small hydrocarbon chains apart from the bigger chain. These branches have each one its own name, and it's assigned by the amount of carbons it has, as the same as in the long chain. But be careful. These branches need to be accommodated exactly by alphabetical. It doesn't matter the prefix it has to be alphabetically arranged. Once it's that, you just arrange the branches first, and then the whole long chain, and you have your name. Now we're gonna make it a little bit clear for you to understand how to name an alkene hydrocarbon by using an example. This example appeals to the explanation given of the steps of how to name an alkene hydrocarbon. As you can see, it has a double bond and a lot of branches, which will be used to name the hydrocarbon. And according to the steps that I previously gave, we're going to name this hydrocarbon according to the following steps. As said in the procedure, we first need to identify if it's an alkene hydrocarbon. We do this by looking at the structure, and we see that there is a double bond. Once we know this, we need to identify the longest chain and count it. It gave us 7, so this is an heptane. The longest chain is an heptane. Then we count the branches. The branches, there's one that has 2 carbons, and that's one that has 1. After counting, we can identify that it's an ethyl and a methyl. According to the law, we need to order them alphabetically. So we put first the ethyl and the methyl. But watch out, you number the hydrocarbons according to the ones that gives you the least amount of branches. This means that the ethyl will be in carbon number 2 and the methyl will be in carbon 4. This means this will end as 2-ethyl 4-methyl heptane. That's the answer.
The general formula of the alkyne is CnH2 and -2, and are the third of the series of organic compounds. In order to name an alkyne, we use this table because it has the 10 possible names with its suffixes. And we look at the longest continuous carbon chain with a triple bond. Then we name it using the suffix of alkyne, that is -ine. And you can start numbering at the end meter from the triple bond. Have here an example. In here, the little part with the color blue indicates that it's a 6-methyl. And if we number these parts, these carbons, atoms, we know that it's a trioctene. So that's the name, 6-methyl trioctane.
Okay, now let's talk about aromatics. First, what is an aromatic? An aromatic, it is a hydrocarbon in form of cycle which has 6 carbon atoms. So this cycle with 6 carbon atoms, it is called a benzene ring. And the benzene ring, it is the simplest form of an aromatic. Okay, we know what is an aromatic. Okay, now we need to know how to name an aromatic, right? To name an aromatic, okay, first let's say here we have the benzene like this, right? Okay, we have it like this, and here we have other hydrocarbons. Okay, now let's say that, okay, here we have the first thing we need to do, the first step, is to number each of the points of the benzene. Why? Because in the moment that we name the compound, we need to know the position in which these hydrocarbons are. Like this. 1, 2, 3, 4, 5, 6. Okay. Now that we number each point of the benzene, here we know that they are in the 1 and the 2. And here we put 1, 2. Okay, but what happened? What is need? Okay, each of these hydrocarbons, they only have 1 carbon atom. So since they only have 1, each of them, it is called a methyl. But since they are 2 of methyl, it is called a dimethyl. Okay, now we already know the position, we already know how it is named, each of the hydrocarbons. Okay, now that we know that, we just put here that it is a benzene. And that's all. This is a good example to know how to name an aromatic. Thank you for your attention.
As a personal conclusion, I think that UPAC rules are super important, because if not, chemists would have problems by identifying the compounds and the chain length and their type of length. And if not, many of the substances we know could be different or like super hard to identify and use.